In computing, data is any information that can be moved, processed, or stored by a computer. A program can acquire data to work with in many ways. From a file or database, over a network, from the user providing input on a keyboard, or from the programmer putting data directly into the source code of the program itself. All computers have memory, called RAM, short for random access memory, that is available for your programs to use. You can think of RAM as a series of mailboxes that can be used to hold data while the program is running. A single piece of data, stored in memory somewhere, is called a value. In C++, direct memory access is not allowed. Instead, we access memory indirectly through an object. An object is region of storage, usually memory, that has a value and other associated properties. When an object is defined, the compiler automatically determines where the object will be placed in memory. In order to create a variable, we use a special kind of declaration statement called a definition. Int x. Define a variable named x, of type int. At compile time, when the compiler sees this statement, it makes a note to itself that we are defining a variable, giving it the name x, and that it is of type int. A data type, more commonly just called a type, tells the compiler what type of value, for example a number, a letter, text, etc., the variable will store. In the above example, our variable x was given type int, which means variable x will represent an integer value. An integer is a number that can be written without a fractional component, such as 4, 27, 0, -2, or -12. In C++, the type of a variable must be known at compile time when the program is compiled, and that type cannot be changed without recompiling the program. This means an integer variable can only hold integer values. If you want to store some other kind of value, you'll need to use a different variable. T is possible to define multiple variables of the same type in a single statement by separating the names with a comma. Int a, int b, is the same as int a, b. The first mistake is giving each variable a type when defining variables in sequence. Int a, int b, wrong, compiler error. Int a, b, correct. The second mistake is to try to define variables of different types in the same statement, which is not allowed. Variables of different types must be defined in separate statements. Int a, double b, wrong, compiler error. Int a, double b, correct, but not recommended. Correct and recommended, easier to read. Int a, double b. After a variable has been defined, you can give it a value in a separate statement using the equals operator. This process is called copy assignment or just assignment for short. Hash sign include int main, int width, width equals 5, copy assignment of value 5 into variable width. Variable width now has value 5. Width equals 7, change value stored in variable width to 7. Variable width now has value 7. Return 0. When a variable is defined, you can also provide an initial value for the variable at the same time. This is called initialization. First, we come to copy initialization by using an equals sign. Int width equals 5. Copy initialization of value 5 into variable width. Second, we can do a direct initialization by using parentheses. Int width 5. Direct initialization of value 5 into variable width. Unfortunately, direct initialization can't be used for all types of initialization. In an attempt to provide a more consistent initialization mechanism, C++ 11 added a new syntax for direct initialization called brace initialization, also called uniform initialization, that uses curly braces. Int width 5. Brace uniform initialization of value 5 into variable width. Initializing a variable with empty braces indicates zero initialization. Zero initialization generally initializes the variable to 0 or empty, if that's more appropriate for a given type. Int width 0 initialization to value. Initializing int width 0 initialization to value 0. Uniform initialization has the added benefit of disallowing narrowing conversions. This means that if you try to use uniform initialization to initialize a variable with a value it cannot safely hold, the compiler will throw an warning or error. For example, int width 4.5, error, an integer variable cannot hold a non-integer value. You can initialize multiple variables defined on the same line. Int equals 5, b equals 6, copy initialization. Int c 7, d 8, direct initialization. Int e 9, f 10, uniform initialization preferred. Unlike some programming languages, C/C++ does not initialize most variables to a given value, such as 0, automatically. Thus, when a variable is assigned a memory location by the compiler, the default value of that variable is whatever garbage value happened to already be in that memory location. #sign include. Using namespace std. Int main / define an integer variable named x. Int x. This variable is uninitialized because we haven't given it a value. Print the value of x to the screen. Caught less than x. Who knows what we'll get, because x is uninitialized. Return 0. First, it is a convention in C++ that variable names should begin with the lowercase letter. If the variable name is one word, the whole thing should be written in lowercase letters. Int value, correct. Int value, incorrect, should start with lowercase letter. Int value, incorrect, should start with lowercase letter. Int value, incorrect, see your psychiatrist. If the variable or function name is multi-word, there are two common conventions. Separated by underscores, or intercapped, sometimes called camel case, since the capital letters stick up like the humps on a camel. Second, you should avoid naming your identifiers starting with an underscore, as these names are typically reserved for OS, library, and/or compiler use. Third, your identifiers should make clear what the value they are holding means, particularly if the units isn't obvious. Identifiers should be named in a way that would help someone who has no idea what your code does be able to figure it out as quickly as possible. Before the assignment statement, RAM contains the user's input. After the assignment, it contains a different value. That's confusing. We overwrote the user's input by assigning a new value to the input variable, so if we wanted to extend our program to do something else with that input value later, for example triple the user's input, it's already been lost. This solution is a pretty straightforward to read and understand, and resolves both of the problems encountered in the worst solution. The primary downside here is that we're defining a new variable, which adds complexity, to store a value we only use once. This is the preferred solution of the bunch. When std caught executes, the expression num*2 will get evaluated, and the result will be double num's value. That value will get printed. The value in num itself will not be altered, so we can use it again later if we wish.